How was the clock made? Have you ever wondered how your day would go if you could never keep track of time? Imagine not knowing what time it is currently, how long until it's finally lunchtime, or what time to wake up tomorrow. Doesn't sound very inviting. Fortunately, we don't live in that reality, and that's all thanks to the invention of clocks. So where did they come from? Where did the concept of time itself come from? If that sounds like a question you want to know the answer to, stick around, because today we'll explore exactly how the clock was made. So, no time to lose. Let's get into it. Early timekeeping. The concept of timekeeping has been around for thousands of years, dating all the way back to when ancient civilizations first observed astronomical bodies as they moved across the sky. Believe it or not, these ancient humans also had busy schedules, you know. They needed a means of keeping track of time to quantify exactly how much time has passed. Clocks, which, fun fact, are also called chronometers, have evolved over thousands of years through distinct eras of innovation. The very first timekeeping devices were all based on the idea of tracking time through the continuous movement of an object. These continuous movements came in many forms. Continuous movement clocks. Take, for instance, the very first devices used for measuring time, shadow clocks, which were later developed into the sundial. These were first used in ancient Egypt around 1500 BC, and later by the Babylonians, Greeks, and Chinese. The continuous process that sundials used to measure time was, you guessed it, the movement of the sun across the sky, or the movement of the shadow cast by the sun, to be specific. You see, when pointed towards the celestial pole, an upright stick or rod on the sundial called the gnomon casts a shadow on the base plate, the length and position of which changes throughout the day. The base plate was often marked and labeled to indicate which shadow corresponds to what time. There were also water clocks, also known as clepsydra, another continuous motion clock which used the gradual flow of water to measure time. Although most likely originating in ancient Egypt, variations of these have also existed across ancient China, Greece, and the Middle East. They consisted of bowl-shaped containers that allowed water to flow at a controlled rate, indicating the passage of time. And then there were candle clocks used in medieval times, which measured time based on the continuous melting of the wax on a candle. The special candles used for these clocks were marked with time intervals, and as the wax melted, it revealed these increments and showed the time. These were simple and very easy to make and use, but of course lacked precision. Finally, and perhaps most notably, was the hourglass, the first truly dependable, reusable, accurate, and easily constructed time-measuring device. It was likely used as far back as the 11th century on board ships, as they were one of the few reliable timekeeping methods at sea. In fact, Ferdinand Magellan used 18 hourglasses on each ship during his circumnavigation of the globe in 1522. From the 15th century onwards, hourglasses were widely used at sea, in churches, in industries, and in cooking. By the way, if you're hooked so far and you'd love to see more like this, you can subscribe to our channel. And to make sure you catch all future uploads, hit the bell icon. Thanks. Now let's move up an era. Mechanical clocks. The next era in the history of clocks came in the shift to mechanical clocks. Although versions of mechanical clocks existed in some capacity, they were all powered by fluids like water or mercury and weren't truly mechanic. True mechanical clocks came about as a result of the verge escapement, a crucial innovation that allowed controlled release of energy, which could be used to regulate the movement of a clock's gears. It involved a verge and foliate mechanism that controlled the gear train's movements and released enough energy to gradually increase the time. The verge escapement greatly improved the accuracy and reliability of early mechanical clocks, and further refinement came with the development of complex gear systems that allowed energy to transmit from the source and precisely move the clock hands. Genius clockmakers such as Richard of Wallingford and Giovanni da Dondi played key roles in advancing this technology, and their innovations paved the way for more sophisticated timepieces. It was around this time, around the 14th century, that saw the rise of clock towers in prominent city centers. These towers housed large mechanical clocks visible to the public, which sounded loud bells each hour. They served a great practical purpose, as they notified the public of the passing of every hour, which was important for religions where prayers were offered at fixed time throughout the day, like Islam, Judaism, and Christianity. They also served a lot of symbolic purpose, often becoming civic landmarks and points of reference within cities. Further advancement came with the invention of the mainspring in the early 15th century, which allowed small clocks to be built for the very first time. These clocks needed a mechanism for escapement that steadily released stored energy, which was achieved by devices called the stackfried and the fusee. This all culminated in the invention of the earliest example of a watch by German clockmaker Peter Henlein in 1524. Pendulum clocks. The Italian polymath Galileo Galilei is thought to have first realized that the pendulum could be used as an accurate timekeeper after watching the motion of suspended lamps at Pisa Cathedral, realizing that the swing of a pendulum only depended on its length and not the weight. Although he could not create a clock based on this discovery before he died, his idea was realized by Dutch polymath Christian Huygens in 1656 with the invention of the first pendulum clock. It used the principles of repeating harmonic motion, in which the motion of a pendulum always repeats at exactly fixed intervals to regulate the clock's movement. His invention was groundbreaking as it increased the accuracy of clocks more than 60-fold. Later versions erred only by about 10 seconds, extremely accurate for that era. This made dials that showed minutes and seconds alongside the hour increasingly accurate. The improvement in accuracy was so massive, in fact, that most existing clocks were refitted with a pendulum instead, which is the reason why so few verge escapement devices have survived in their original form today. Accurate timekeeping greatly helped with navigation, as sailors could now use it to determine their longitude, and also with science, as scientists could now accurately time their experiments and observations. Role of Industrial Revolution. The arrival of the Industrial Revolution, as it did for so many creations, changed the game for clock production with the advent of mass manufacturing techniques. High-quality clocks became more affordable and accessible than ever to the broadest possible audience. This is where clockmaking shifted from artisan workshops to large-scale industrial factories, where all components were standardized. A fun advancement of this time was the cuckoo clock, with its distinctive bird call at each hour, originating in the Black Forest region of Germany. It was known for its charming design and became a symbol of craftsmanship, often being inlaid with intricate woodwork. The 18th and 19th centuries also saw the rise of pocket watches as a portable and fashionable accessory. They became popular among the upper class and were often finely crafted with ornate cases. Pocket watches were crucial to the development of personal, portable timekeeping. Electronic and atomic clocks. In the mid-20th century, electronic clocks began to take over and replace mechanical ones. They used electronic components like transistors and integrated circuits for highly accurate timekeeping. The first battery-driven electronic watches were developed in the 1950s. This was soon followed by further advancement in the form of quartz-powered watches, which made use of the piezoelectric properties of quartz crystals to create very accurate time oscillations. The world's first quartz wristwatch, the Astron, was released by Seiko in 1969. The most accurate timepieces in practical use right now are atomic clocks, which use the vibrations of atoms, often cesium or rubidium, to measure time extremely accurately. The natural frequency of their atomic vibrations serves as a stable reference for timekeeping and leads to unprecedented accuracy. Atomic clocks have become fundamental to scientific experiments, telecommunications, and GPS in today's world. As you can see, clocks have a history of improvements and innovations. We've gone from using rudimentary points of reference like wax or sand to using the vibrations of atoms to measuring time. Nothing illustrates our advancement in technology quite like that. And there's no sign of us stopping anytime soon. Nowadays, accurately telling the time is the least impressive thing a watch can do. Watches have become portable computers on our wrists that allow us to communicate with others around us and access any kind of information we might need. Hope you learned something from this video. Thanks for watching.